Hello dear children and welcome back to the class. Dear friends, today we are going to learn about the chapter number 2, periodic classification of elements. The objective of the lesson are elements and their classification. In this chapter, we are going to learn about the demerits triads, Newland's law of octaves, Mendeleev's periodic table, and modern periodic table. Let's begin with the classification of elements. We have already learned in the previous standards that all the atoms of an element are of only one type. Dear children, today's modern periodic table contain 118 known elements. In the year of 1800, only 30 elements were known. More elements were discovered in the course of time. We are going to learn about the classification of elements by the respected scientist demerits triads. Let's begin with the classification. Demerits triads and Newland's laws of octaves were early attempts at classifying elements into groups based on their properties. Since many elements were discovered over the course of the 18th and 19th centuries, the broad classification of elements into metals and non-metals became insufficient. Several experiments were conducted in order to identify elements with similar properties and group them together. It is important to note that the primitive methods of classifying elements such as demerits triads, Newland's laws of octaves laid the foundation for the development of the modern periodic table. What are demerits triads? Demerits triads were groups of elements with similar properties that were identified by the German chemist Demerits. He observed that the groups of three elements called triads could be formed in which all the elements shared similar physical and chemical properties. Demerits stated in his laws of triads that the arithmetic mean of the atomic masses of the first and the third element in a triad would be approximately equal to the atomic mass of the second element in that triad. He also suggested that this law could be extended for other quantifiable properties of elements such as density. The first demerits triad was identified in the year of 1817 and was constituted by the alkaline earth metals calcium, strontium, barium. Three more triads were identified by the year 1829. Let's begin the Newland's law of octaves. In the year of 1864, the British chemist Newland attempted the 62 elements known at that time. He arranged them in an ascending order based on their atomic masses and observed that every eighth element had similar properties. On the basis of this observation, Newland's law of octaves was formulated. The law of octaves states that every eighth element has similar properties when the elements are arranged in the increasing order of their atomic masses. An illustration detailing the elements holding similar properties as per the Newland's law of octaves is provided below. Newland compared the similarities between the elements to the octaves of music, where every eighth note is comparable to the first. This was the first attempt at assigning an atomic number to each element. However, this method of classifying elements was met with a lot of resistance in the scientific community. Let's see the limitations of the Newland's law of octaves. Number 1. Several elements were fit into the same slots in Newland's periodic classification. For example, cobalt and nickel were placed in the same slot. Elements with dissimilar properties were grouped together. For example, the halogens were grouped with some other metals such as cobalt, nickel and platinum. Newland's law of octaves held true only for elements up to calcium. Elements with greater atomic masses could not be accommodated into octaves. The elements that were discovered later could not be fit into the octave pattern. Therefore, this method of classifying elements did not leave any room for the discovery of new elements. This is all about the Newland's law of octaves. Let's begin with the Mendeleev's periodic table. What is Mendeleev's periodic table? Dear children, Mendeleev's periodic table is an arrangement of elements in an increasing atomic masses, ordered in a table form such that it reflects similarities and trends in the behavior of elements. How Mendeleev arranged elements? Yes, dear children, Mendeleev initially arranged elements one below the other in the order of increasing atomic weight. Elements having similar properties are placed nearby. Elements with similar properties are found in the same horizontal row. Mendeleev's original periodic table published in the year of 1869. Mendeleev's periodic table can be understood better by reversing the arrangement of the elements. Here, elements are arranged in an increasing order, atomic mass, in a horizontal line. This horizontal arrangement of element is called period. When an element has high similarity to the earlier element, the new element is placed just below the earlier element, having similar property to start a new period. The periods one below the other form, that is a column called group. Mendeleev's periodic table consists of horizontal rows and vertical columns or periods and groups respectively. If the element is similar but not very much, it is placed below but slightly away to differentiate it. Each column will have two subcolumns A and B such that elements in the subcolumns show more resemblance. Mendeleev organized the periodic table on the basis of the chemical and physical properties of the elements. These were the molecular formula of hydrides and oxides of the elements, melting points, boiling points, and densities of the elements and their hydrides and oxides. Mendeleev found that elements with similar physical and chemical properties repeat after a definite interval. Mendeleev stated that the properties of elements are periodic function of their atomic masses. The vertical column in the Mendeleev periodic table are called groups, while the horizontal rows are called periods. Now let's see the merits of Mendeleev's periodic table. Number 1. While applying the law that the properties of elements are a periodic function of their atomic masses to all the known elements, Mendeleev arranged the elements with a thought that the information available till then was not final, but it could change. As a result of this, Mendeleev's periodic table demonstrates the following merits. Number 1. Atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. For example, the previously determined atomic mass of beryllium is 14.09 was changed to the correct value 9.4 and beryllium was placed before the boron. Second, Mendeleev kept vacant place in the periodic table for elements not discovered till then. 3 of these unknown elements were given the names Eka boron, Eka aluminium and Eka silicon from the known neighbors, and their atomic masses were indicated as 44, 68 and 72 respectively. Not only this, but their properties were also predicted. Later on, these elements were discovered and named as scantium, gallium and germanium. It means that the Eka boron is nothing but the scantium, Eka aluminium is nothing but the gallium, and Eka silicon is nothing but the germanium. The properties of these elements matched well with those predicted by the Mendeleev. There was no place reserved for noble gases in Mendeleev's original periodic table. When noble gases such as helium, neon, argon were discovered towards the end of 19th century, Mendeleev created the zero group without disturbing the original periodic table in which the noble gases were fitted very well. This is all about the merits of Mendeleev's periodic table. Let's see the demerits of Mendeleev's periodic table. First, the whole number atomic mass of the elements cobalt and nickel is the same. Therefore, there was an ambiguity regarding their sequence in Mendeleev's periodic table. Second, isotopes were discovered long time after Mendeleev put forth the periodic table. What do you mean by isotopes? Isotopes have the same chemical properties and different atomic masses. A challenge was posed in placing them in Mendeleev's periodic table. Third point or third demerit, when elements are arranged in an increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. Fourth point, position of hydrogen. Hydrogen shows similarities with halogen, means group 7th. For example, the molecular formula of hydrogen is H2, while the molecular formula of fluorine and chlorine are F2 and Cl2 respectively. In the same way, there is a similarity in the chemical properties of hydrogen and alkali metals. Group first. There is a similarity in the molecular formula of the compounds of hydrogen alkali metals. For example, sodium and potassium formed with chlorine and oxygen. On considering the above properties, it cannot be decided whether the correct position of the hydrogen is in the group of alkali metal or is in the group of halogens.